Hello, everyone, and welcome to today's webinar, How PG&E Uses Prefabricated Buildings to Bolster Resilience, Reliability, and Safety. We're excited you could join us. My name is Megan Billingsley, and I'll be moderating today's event. Today, we are going to dive into a topic that often doesn't arise in discussions about grid reliability and resilience, and that is the role of prefabricated buildings. Everybody attending the webinar today knows that the utility landscape is changing rapidly, creating both opportunities and challenges. Whether it's the threat to the reliable delivery of energy posed by increasingly extreme weather, or the rapidly accelerating demand for electricity, utilities need to move more quickly and proactively than ever before. But amid all the changes that utilities must navigate, the overall mission remains the same: to make decisions and investments that serve rate-paying customers. One way that Pacific Gas and Electric, or PG&E, has cost-effectively bolstered resilience, reliability, and safety for its customers is through its embrace of prefabricated buildings in the construction and maintenance of substations. We're going to learn today about PG&E's use of prefabricated buildings to meet the utility's unique demands for substation projects. We're also going to hear from Trachte, a leading supplier of prefabricated buildings for the utility industry. Trachte will provide its perspective on utility use cases and trends around the use of prefabricated buildings. We are thrilled to be joined by two speakers today: Chad Dupuis, electrical engineer, principal, Pacific Gas and Electric, or PG&E, and Dan Smith, regional sales manager with Trachte Invent. Before we get started, I have just a few housekeeping items. Please note the slides will advance automatically throughout the presentation. To enlarge the slides, click the Enlarge Slides button located in the top right corner of your presentation window. If you need technical assistance, click on the Help widget located on the bottom left corner of your console. We encourage you to submit questions at any time throughout the presentation using the Q&A widget at the bottom of your console. We will try to answer these during the webcast, but if a fuller answer is needed or we run out of time, it will be answered later via email. Please know we do capture all questions. So to kick off, I'd like to ask each of our speakers to provide a quick introduction of themselves and their work. Dan, how about you start?
Yeah, thank you. Dan Smith with Trachte Invent. I'm the regional sales manager that covers the Western United States, and I've been with Trachte for 3 years now.
Thank you, Dan. And Chad, can you give the audience a description of your role at PG&E?
Hi, everyone. I am with PG&E now for since 2020, so about 4 years as a direct hire. I first started working on PG&E projects as a contractor in 2010 with our power generation line of business, hydro, as it's known. I've been an engineer of record for replacement of distributed control system at our PG&E Helms pump storage power plant. I've worked on more than 300 capital projects for PG&E in hydro generation, gas department, and substation lines of business. I am presently the subject matter expert for flexible AC transmission systems, and also provide ongoing SME support for control battery impact buildings, HVAC systems, fire protection systems, and a number of other systems at PG&E. Most recently, we have completed 22 technical improvement projects related to modular buildings, which is a mature program at PG&E, including having developed content with PG&E Academy for a new in-class training covering topics about PG&E modular buildings, for which I was a class instructor.
Excellent. Glad to have you both with us. And with that, I think we're ready to dive in. So Chad, I'd like to start with you. Can you give us some context around how PG&E evolved to use prefabricated buildings in its substation construction projects?
Buildings have always been used to facilitate PG&E's construction of new facilities at substations. We can't do any project without a building that encloses our protection and automation and control systems. Those systems need to be protected because they are the brains of our substation. In the past, PG&E would construct those buildings on site toward the end of the 90s, there were some innovators at PG&E who were looking for a way to improve the way we perform new construction within electric substations. There were several reasons PG&E was interested in new approaches to substation projects that involved the construction of buildings on site. For example, PG&E wanted more predictability around our operative date. We had lots of projects that were being delayed for various reasons, and often the building controlled the project schedule. There were also lots of inefficiencies with on-site construction. We had materials at the end of the job that were waste. We had a lot of construction folks in the field. We had some quality issues. We also have a system that is geographically diverse. It's coastal, mountainous, in the desert. Many substations are in places far from where our resources are located. That means mobilization to any one of our locations can be very difficult. It means setting up people to live temporarily and bringing materials to the site. Initially, we had the idea that we could be more efficient and deliver a building on a schedule that was better if we used prefabricated buildings. But there is a lot to developing a prefabricated building that could meet our needs. There are structural, mechanical, electrical, automation, protection, control components, and architecture that are proprietary to PG&E within that container. Beyond that, we need to make sure that prefabricated buildings facilitate our construction projects to enhance safety, technical, quality, delivery, responsiveness, and cost.
Excellent. Thank you, Chad. So, Dan, let's bring you into the conversation. Trachte works with a lot of utilities, and I'm wondering if you could add anything to what Chad said about why utilities are increasingly using prefabricated buildings.
Absolutely. Yeah. Thank you for the question. I think as Chad dove in, I think he's mentioned quite a few of these, right? It's the quality, the safety, schedule, and really being able to meet the demands of a geographically diverse utility in their own right. But for us as a vendor, really servicing all of our customers from coast to coast. I think one topic that's top of mind for Trachte and really all of our customers is safety. And when we look at prefabricated buildings and what we do with that being our core product is really our ability to limit our time within a customer's site, right? Anytime you're inside of a substation, there's massive safety implications, right? And being able to mitigate those as best as we can through a number of different avenues is crucial. But the main one being by building that building in a quality controlled factory under our own roof and limiting our time within a customer's site is a huge advantage, right? For both our customers and for us, but really removing a lot of the safety, the potential safety issues that would pose if we were to build that building on site. I think what we've seen is a shift, right, in the market. Trachte's been building steel buildings for a lot of years, and in the power industry specifically, and so I think that's been one really big advantage and why we've seen the market sort of shift to the prefabricated style of construction for this particular application. So I would say that's really, priority number one is safety, both in our factory when we're building these, but then also how we deliver to our customers. I think the other one, just to build off of that, is quality, right? We're able to own all the quality of that building in our factory and allow our customers to do a factory acceptance test prior to the shipment of that building, so that we're really meeting the demand that our customers have of us prior to delivering the building to site. So I would say that those are two really big key factors that we see with our customers, and why we would argue that the industry has kind of shifted to the prefabricated style of construction.
Excellent. Thank you so much. So, Chad, let's go back to you. How does the use of prefabricated buildings in substation projects connect to larger goals around serving customers and improving the resilience and reliability of electricity supply?
Yeah, you are right to focus in on the customer benefit. The reason why we do this is to serve our rate-paying customers better. Without our rate-paying customers, we don't have a business and we don't have a utility. This goes back to the reasons discussed earlier. The customer sees cost on their utility bill. If we are not using prefabricated buildings that deliver efficiencies to how we do our substation projects, they will likely see a higher cost on their bill. Cost is also connected to quality. If we can't build quality systems, the cost will be higher. And we're not delivering projects in a timely way, the businesses and residents, commercial customers, government customers who rely on the utility will feel it directly in higher costs. Our customers may not directly see our safety record, but indirectly, when we're safe, they're safe. I always come back to the same thing. Our business is about serving our customers safely and cost effectively. I'm sure everyone on this call is thinking about grid resilience and reliability. Everyone hears about the forest fires in California. While they are an important risk, fires are not the only risk to our operations. In everything we do as a utility, we are designing for reliability and resilience in the safest possible manner. Reliability is our ability to function the way we need to function. For example, we're an earthquake country in California. We want our substations to function through and following the earthquake without any interruption to service. But if something does happen at a substation, we want to have the resiliency to be able to put it back into service in the quickest possible time. When we have the standardized construction that comes with prefabricated buildings, it speeds recovery and repair. One final topic I want to raise about modular protection, automation, and control program at PG&E, known as MPAC, is a standard that we developed for buildings that are serving projects that are typically above 100 kV of AC line voltage, and that we have to comply with NERC and FERC because of these standards. The compliance around those projects demands a heightened degree of care, and that we use that program to manage that. MPAC has deployed prefabricated modular purpose-built buildings faster than conventional building construction to speed the pace to safe, clean, affordable substation projects for 20 years. The MPAC program aims to deploy pre-engineered, fabricated, pre-wired, standardized buildings and often executed in an integrated manner with other capital projects, such as capacity expansion projects, bus conversions, aging asset replacement, reliability, etc. There's a long list of advantages prefabricated buildings provide. Reduced cost and fast repairs are a big advantage. This includes for repair or replacement of exterior and interior wall panels, customizations like exterior paint, floors, and seismic reinforcement. PG&E has installed over 130 prefabricated buildings over the last 20 years. We have demonstrated over the years the MPAC program is the best way to deliver new buildings for substations supporting grid expansion, modernization, and grid enhancing technologies. I should say that 2/3 of our prefabricated modular buildings are not part of the MPAC program. You might conclude that we're not constructing above 100 kV, but that's not entirely true. we can still achieve the same standard of compliance and construction above 100 kV, not using the MPAC program. The larger point is that MPAC is more than just a standard. It's a contract delivery model. And the contract delivery model for MPAC is that we have our buildings furnished and pre-wired, pre-assembled offsite before they ship to the final installed location. Includes a floor, and we set it on a foundation at PG&E. When managed under a program, modular buildings can be planned, designed, furnished, installed, and commissioned into service more safely, efficiently, reliably, and affordably than alternative methods. We've also found that working with a well-established building vendor offering the prefabricated or panelized modular construction can perform to standardized requirements, and that's essential. One of the reasons we use the MPAC program is because of the speed with which we can deploy the buildings. The MPAC program covers the cases where we need to deploy rapidly, and we need to deploy to a standard that we know our vendors can deliver. We have demonstrated over the years the MPAC program is the best way to deliver new buildings for substations supporting grid expansion, modernization, and grid enhancing technologies.
Excellent. Thank you, Chad. So Dan, I want to turn back to you now. Can you talk about how Trachte approaches innovation?
Yeah, absolutely. So I think, one source of innovation with Trachte in our installed base or our customer base is that we're working with clients, as I mentioned, in the last question, from coast to coast, from the East Coast to the West Coast, the Gulf states, the Southwest to the Pacific Northwest. So we're met with a lot of different challenges from a weather perspective and a whole host of different things that happen within those climates and those different geographic regions. And what we see from customer to customer, it varies, right? Sometimes it could be super, super similar, and sometimes it's very different, right? At its core, what we're providing is a prefabricated control enclosure or building. But what we're able to do is take all of those different best in practices, if you will, from utility to utility or renewable contractor to contractor, and provide that expertise to our entire customer base. And what that's allowed for us is to bring what's happening with one customer to another. And maybe there's a fit that helps that customer deploy a better building into the field, and really be able to share that with all of our customers. And that's really led to a powerful message, and allowed the industry to be collaborative in how we build these buildings, how we innovate these buildings. What happens here may differ from what happens there, and we're able to take that and really continue to drive forward with innovation. An example of that, very, very simplistic, but very practical, with customers in an area with high wind and snow loading requirements. We needed to develop something for the door area, right? There was snow buildup, high wind with the door open was causing issues, right? That was a service issue for us after the fact because of those conditions. And we developed putting a vestibule on that building to prevent the snow buildup in front of the doors swinging open because of the wind. So again, what seems like such a, in someone's eyes, maybe non-interesting innovation practically became a really awesome addition to that building that solved needs. And we were able to take that to other customers, which allowed us to really provide more value, right? We saw this here, but that application works over here. And I think that's industry collaboration, right? It's not Trachte necessarily reinventing the wheel, but working with our customers to find those solutions and then share those across the industry so that we all win in that scenario. And then I think, Chad touched on it a little bit, but one thing Trachte does really well from an innovation standpoint. I think one thing that really makes us stand out and allows Trachte to be such a flexible, nimble vendor to the industry is our ability to build buildings with and without floors to really match what our customer needs are, right? Chad talked about their MPAC program and how that delivers to their customers. And we have other customers who have different models, right? And so being able to cater the building style with a floor or without a floor and these different componentry has allowed us really to serve the market and serve our customers in a positive way and really drive towards the results that they ultimately need out of the prefab enclosure that they're looking for. So just some examples of innovation around the building.
Excellent. Thank you so much. Chad, can you talk about how PG&E has approached innovation of your MPAC program or other prefab control buildings?
Sure. Our approach to prefabricated building innovation is grounded in our experience. In other words, innovation is driven by the needs we observe as we're using the buildings. One recent example is we noticed an issue with rodents getting into buildings that highlighted the need to develop a cable entrance closure that prevents rodents and weather, including smoke or dust, from getting into the buildings through cable entrances. Once we identify a need that can be addressed by innovation, we work to pilot and trial a solution to make sure it really does make the building better and is more suitable for meeting our needs. I want to add something more generally about innovation. At PG&E, we've defined the areas where we want to focus on innovation. They include safety, technical, delivery, responsiveness, and cost. To be more specific, we want innovation to improve these, shorten delivery times, reduce costs without adversely impacting the other categories. What I want to emphasize here is that innovation doesn't stop, and we continuously drive toward improvement in each of those areas. One safety-related innovation we have implemented is around the large wall-mounted HVAC units that are placed onto some of our buildings. These units need to go on the buildings in ways that reduce the chance of dropping the HVAC unit when removing or putting the unit on, misaligning it. We need to handle the equipment in a way that makes it safer, but also easier to align. We identified ways to use handling equipment for those units that integrate self-leveling and maneuvering that help improve safety and alignment.
And Chad, what is PG&E's roadmap for prefabricated modular buildings? And are there specific changes coming as digital substations become more common?
I think of the day when we use a much smaller building footprint. We are continuing to move into the area of digital substations where we will see a redistribution of the computing, digitalization equipment in the substation. Today, we have hardware and software that performs electrical protective functions, but as we evolve, more of that function will be handled by software. That allows for miniaturization in the footprint of that equipment and in reducing the size of the building. This is pointing us toward a physical building that encloses less rather than more. That's good news if the miniaturization model leads to an overall net decrease in footprint and form factor for the substation. This allows us to put more within a lesser footprint. Our roadmap is focused on the topic of miniaturization. How can we get more into less space? What are the ways that we can continue to improve? We don't look at innovation as a goal in and of itself. it's about driving affordability, safety, reduced environmental impact, and added value for PG&E customers and employees.
Excellent. Thank you both so much. Lots of great insights shared. We do have some time left, so I'd like to shift to some questions from our audience in the time that we have remaining. Just to jump right in, we've got one here for Chad. What advice can you give to other utilities about the role of prefabricated buildings in substation projects and any trade-offs with on-site buildings?
Yeah, that's a great question. You know, prefabricated buildings are a better option to consider for places where you have, say, construction resources who may be tied up or have skill levels on things unrelated to the building. Having a prefabricated building allows you to use those resources where they may be best applied, and not having, say, to add resources that are specifically devoted to the construction of the building. There are locations around, as I mentioned earlier, our service territory where prefabricated buildings may have a floor. This is in the impact delivery where our equipment is installed and pre-wired. But there are other locations where we may have the resources to sort of build out the interior spaces of the building, in which case we may not use a floor. It may be shipped floorless, and we can set it on a PG&E foundation. There are locations where we also may want to leverage modular buildings, but doing so with panelized construction, where it will be difficult, even if we split the building, to get the building to its final installed location. So having panelized construction allows us to control the width of and the weight of the load. We have some locations where we cross bridges. Bridges have physical constraint, capacity constraint. So having panelized construction allows us to move a building over bridges that can sustain the weight that we can tailor. And then at PG&E, I mentioned that we also do some traditional construction. And in these cases, it may be, as I said, resource-based, site-specific based, and we still do build buildings, traditionally, where the pieces are shipped and then erected on site.
Excellent. Thank you. Dan, we've got one here for you as well. What is Trachte's roadmap for advances in prefabricated buildings?
Sure. I think it's a great question. I think for Trachte, our roadmap on the future of prefabricated buildings really hinges on being able to meet the demands of our customer and really meet them wherever they're at. I think the question really ties into the previous question that I spoke on regarding innovation and being able to meet where the industry is going, right? Increasing demand for ballistics protection for buildings, EMP design. I know Chad talked extensively about the future of digital substations and the hope to reduce footprint, but and not to contrary that, but we've seen some utilities and some customers grow the size of their buildings and being able to meet the demand of complex, large-scale projects and being able to meet those demands. We look at the future of data centers and really what that's doing to our business, right? Both on the substation side and the power delivery side, and being able to meet those demands. and really just being able to get a prefabricated building to our customer site, right? Delivering exactly what they're needing. And so I think it's a combination of all those different things, but ultimately I think the statement really is being able to meet our customers, where they're at with the changing environment that is the overall electrification of our grid.
Excellent. Thank you. All right, so Chad, I think we have one more for you as well. Can you say more about scenarios when prefabricated buildings are the right choice and when on-site is the better solution? And what factors do you examine?
Yeah, so it's a good question, and I'll try to give you a simple answer. We look at the safety, the cost, the delivery schedule, the quality, the ability to achieve standardized construction, and if we can achieve that with a prefabricated building, then for the reasons we discussed earlier, there are advantages, right? When we have a vendor who is able to build a site erected building at a location where one or more of those criteria may be met, then it's a good option. The one of the things about prefabricated modular is that it is something that can be scaled in volume much more than, say, traditional site erection, building erection. So it's very dynamic in terms of looking at all the reasons and the benefits for prefabricated buildings. The one thing about prefabricated modular is that as the number of shipping splits increase, or as the width of the building increase, these are factors that drive up cost and that take us in a different direction from what our standardized construction will be. And there are those scenarios where that occurs legitimately, and maybe site erected building is the way to go. But as I said earlier, the majority of PG&E's construction is prefabricated modular. So I think it's important to just understand the objectives you're trying to achieve and have the prefabricated modular as a tool to achieve that. And at PG&E, present day, a substantial number of our buildings are prefabricated.
Excellent. I think that's a great note to end on for today. I'd like to thank our speakers, Chad and Dan, for a great discussion. We appreciate you sharing your insights and expertise with us. And I'd also like to thank our audience for joining us today. We hope to see you again soon. Have a great day.